Benthic macroinvertebrates are animals without a backbone. They're visible to the naked eye and live on river bottoms. Because of their sensitivity to physical and chemical changes in their habitat, they are excellent indicators of the overall health of the river. Among this group are insect larvae, crustaceans, and mollusks. Collecting macroinvertebrates requires many different pieces of equipment. Take the time to familiarize yourself with this equipment before going into the field. There are two methods for sampling macroinvertebrates. The physical characteristics of your site will determine which method you use, either a method for fast currents or one for slow currents. A fast-flowing river is characterized by a water flow with turbulence on the surface and a large-scale substrate made up generally of boulders, stones, and gravel. If your site matches this description, you should use the method for rocky riverbeds. On the other hand, a slow-flowing river is characterized by a calm surface and often has aquatic plants. The riverbed is generally made up of fine, silty, or sandy substrates. If your site matches this description, you should use the method for muddy riverbeds. Whichever method you use, remember that sampling macroinvertebrates is always done from downstream to upstream in order to avoid stepping on and disturbing the habitat to be sampled. Two types of nets can be used with this method: a 1 square meter kick net or a D-net. If you use the kick net, you'll generally need 4 to 6 people. From the riverbank, inspect the study site to find good sampling spots. Look for areas with a good current and a riverbed made up of stones with a diameter of 5 to 25 centimeters. Move downstream from these spots and carefully enter the water. Move up the current toward your sampling site, in other words, from downstream to upstream, and avoid stepping in areas where you plan to sample for macroinvertebrates. Gently lower the net into the water. At the sampling site, 2 team members hold the net. It should be placed in the water facing the current, with the wide cloth strip held firmly on the river bottom to ensure that no macroinvertebrates escape underneath the net. You can stand on the cloth strip to hold it in place. The net should be stretched so that it forms a pocket in which to trap the organisms. It is generally preferable to lean it slightly downstream. 2 other team members stand ready to dislodge macroinvertebrates. The sample should be taken from a 1 square meter section of riverbed, measured in a straight line upstream from the net opening. Now it's time for the 2 team members responsible for dislodging the macroinvertebrates to get to work. Wearing long gloves and equipped with fine bristled brushes, they begin sampling by lifting up the stones within the sample perimeter and vigorously rubbing them beneath the water in front of the net, so that they dislodge any organisms adhering to the stone's surface. Once cleaned, the stones are placed back in the water outside the sample perimeter. For large rocks that cannot be lifted, simply brush the surface. To dislodge organisms buried in the riverbed, dig into the riverbed and stir up the sediments. A 5th team member is in charge of keeping track of the sampling time, which is 2 minutes per sample. The stopwatch is started as soon as the net is placed in the water. Don't put the net in the water until everyone is ready. After the 2 minutes are up, the team members holding the net lift it, pivoting the bottom upstream until they are holding it horizontally above the water. They then take the net to the riverbank, where a 6th team member is waiting with a collection tub to collect the macroinvertebrates. To collect the macroinvertebrates trapped in the net, place it vertically over the tub and rinse it with clean water from the river. Use entomological tweezers to remove the most tenacious ones. Do 3 2-minute samples in different areas of your 10-meter sampling site. All 3 samples should be placed into the same tub and will make up your final sample. Make sure you remember to rinse and dry the net after you have finished with it. The D-net method is the sampling method that meets scientific criteria. The sampling procedure, which usually requires 2 to 4 people, is as follows. From the riverbank, identify riffles and fast-flowing areas, such as runs. These are the only suitable areas for this technique. By definition, a riffle is an accumulation of rocks or an abrupt slope that causes high turbulence on the water's surface. Runs, on the other hand, are areas where the slope is gentler than in riffles, but more pronounced than in pools. The water's surface usually has some eddies and small waves. Take 20 samples lasting 30 seconds each around your sampling site. Samples can be taken by a single team or by different teams. If more than one team is available at the same time, samples can be taken simultaneously. The important thing is to begin sampling downstream and avoid disturbing subsequent samples. Ideally, you should cover your entire site while trying to sample at different depths and current speeds in riffles and runs. To make it easier to clean your net, we recommend that you place the net seams on the outside. Once you have identified a suitable site, you can begin sampling. One person immerses the net into the water, making sure it is placed firmly on the riverbed with the opening facing the current. The stopwatch is started as soon as the net enters the water. For 30 seconds, a second team member dislodges organisms by vigorously brushing stones found within a perimeter 50 centimeters long by the width of the net. A third team member keeps track of the time, which is 30 seconds per sample. Don't forget to also keep track of the number of samples you have taken. After thoroughly cleaning off all the stones in the perimeter, dig your hands into the riverbed to dislodge any organisms buried there. Once the 30 seconds are up, the net is immediately removed from the water. We recommend emptying the net after each sample. How to clean the net is explained in the section entitled Emptying Your Net on this DVD. If several teams are working on the same sampling site, it is important to combine all the samples taken for that site. It is advisable to empty your D-net as often as possible, ideally after each sample, because the force of the current and the substrate could damage the macroinvertebrates trapped in the net. To empty your net, just turn it inside out over your tub or wire mesh bucket. Most of the net's contents will fall out. You can do a thorough cleaning after the last sample. To make sure you don't lose anything that might be left in the net, take care to put the net back in its original position after you empty it. After the last sample, clean the net thoroughly by using tweezers to remove any macroinvertebrates that might have become trapped in the mesh. Finally, rinse and dry the net properly for the next time it is used. If you collect your sample in a plastic tub, make sure you don't overfill it with water when rinsing or cleaning the net. Your tub should not have more than 2 centimeters of water in it. A wire mesh bucket is a very useful sampling tool. It allows samples to be thoroughly rinsed and cleaned before they're placed in a pot or tub for sorting and identification. A sample that is free of silt and clay and large debris makes the next steps that much easier. The goal of sorting the macroinvertebrates is to group similar organisms in your sample together. To do the sorting, use a pair of tweezers or a pipette with the end cut off. Sorting occurs in 2 stages. The initial rough sorting lasts 10 minutes. Then the subsampling lasts 5 minutes. Respecting these time limits is extremely important because they are part of Adopter River's scientific protocol. If at all possible, we recommend that you do your sorting on a table or some other raised surface so that you'll be more comfortable. The goal of the initial rough sorting is to highlight as many different macroinvertebrates in your sample as possible. Use ice cube trays to group similar organisms. Be aware that certain macroinvertebrates are very small, and they can even be almost transparent. Keep your eyes open and study your sample very carefully so you don't miss any. The goal of the sub-sorting is also to highlight the sample's diversity as much as possible, but this time concentrating on a smaller subsample. Use a ladle to take subsamples that you then place in smaller containers. As a team, continue to remove all the different macroinvertebrates that you find for a period of 5 minutes. Even if there are macroinvertebrates remaining in your samples, make sure you stop sampling in order to respect the scientific protocol. When the time has expired, place your sample back in the river and rinse your containers with clean water. If you plan to do identification in class or in the lab, transfer the contents of each compartment of your ice cube trays into watertight containers. Your sample can be kept for a few days in a refrigerator. However, we advise you to do the identification on the same day. Otherwise, predators within the container will compromise your result. Also, dead macroinvertebrates may be harder to identify. Once you have finished sorting, it's time to count and identify the macroinvertebrates you have collected. To do this, use the Visual Identification Key to Freshwater Benthic Macroinvertebrates poster format, along with the Macroinvertebrate Identification Key that can be found in the program guide. For each ice cube tray compartment, identify the order to which the macroinvertebrates belong. If a specimen happens to be mis-sorted, place it in the proper compartment of the ice cube tray. Some macroinvertebrates can move quickly and may change compartments or even try to escape from the ice cube tray. Be alert. For each order, examine your sample and determine the number of kinds it has. You are now ready to complete the Counting Macroinvertebrates field chart. Simply count the number of macroinvertebrates in each order and the number of kinds. But be aware that for certain orders, the field chart lists specific kinds that you must identify and count separately. For example, for the order Diptera, the Tipulidae are recorded separately. So it is important that you don't recount them when counting the Diptera as a whole. Then, all that remains for you to do is enter these data into your internet report to obtain the index of the river's biological health for your sampling site or sites.